You've seen it hundreds of times, maybe thousands. That weird little lump sitting on your laptop charger cable, right near the end, looking like the wire swallowed something it shouldn't have. You've probably touched it, maybe even squeezed it out of curiosity, and then just moved on. Never thought about it again. But here's what's strange. That tiny cylinder isn't decorative. It isn't a manufacturing defect. And it definitely isn't just extra plastic to bulk up the cable. That little bump is quietly doing one of the most important jobs in your entire charging setup. Every single time you plug in. And the reason it exists will change how you see every cable in your home. So today, we're pulling back the curtain on one of the most overlooked pieces of engineering in everyday electronics. Stay with us, because by the end of this, you'll never look at a charging cable the same way again. Let's start with the obvious question, what actually is that thing? That cylinder isn't solid plastic. What you're holding when you squeeze it is a housing, a protective casing, for a component called a ferrite bead. It goes by a few names depending on who you ask. Ferrite core, ferrite choke, EMI suppressor. But regardless of the name, the thing inside that plastic shell is a small ring made from a material called ferrite. Ferrite is a type of magnetic ceramic. It's usually made from iron oxide, essentially a refined, engineered form of rust, combined with other metallic compounds. It sounds simple, but the physics of what ferrite does to electrical signals is genuinely remarkable. The cable itself runs straight through the center of this ferrite ring. So when you look at the outside, it just looks like the wire got thick for no reason. But what's actually happening is that the cable is passing through a magnetic core that selectively interacts with the electrical signals traveling along it. This design is decades old. Engineers figured out early in the development of modern electronics that cables were a problem, not just for carrying current, but for what they accidentally carry alongside. To understand why anyone would bother engineering this solution, you first have to understand the problem it's solving. And that problem is something most people have never even heard of: electromagnetic interference, or EMI. Here's what happens inside your devices. Modern electronics, laptops, phones, chargers, almost anything with a circuit board, don't use electricity in a smooth, steady flow. They switch power on and off at incredible speeds, sometimes millions of times per second. This rapid switching is fundamental to how digital electronics work, but it comes with an unintended side effect. Every time electricity changes direction or speed inside a wire, it creates a tiny electromagnetic pulse. One pulse is nothing, but millions of pulses per second happening across dozens of components. That adds up to a constant stream of high-frequency electrical noise radiating outward from your device and its cables. Your charging cable, in particular, behaves almost exactly like an antenna. It's a long conductor running through space, and antennas don't discriminate. They transmit and receive signals whether you want them to or not. So your cable is constantly broadcasting electrical noise into the room around it and simultaneously picking up interference from everything else nearby. Your Wi-Fi router, your microwave, your neighbor's electronics. Now imagine all of that noise flooding into your laptop's internal components. Or worse, your laptop's noise bleeding into other sensitive devices around it. Speakers start buzzing, screens develop subtle flickers, wireless connections become unstable, data errors creep into transfers. None of these issues are dramatic enough to make you think EMI problem. They're just annoying, unexplained, and persistent. That's the problem the ferrite bead exists to solve. The elegant thing about a ferrite bead is how precisely it targets the problem without touching anything else. When electrical signals travel through a wire passing through a ferrite core, the core interacts with those signals based on their frequency. Low-frequency signals, like the steady DC power your laptop needs to charge, pass through almost completely unaffected. The ferrite core essentially ignores them. But high-frequency signals, the rapid chaotic noise created by switching electronics, the ferrite core resists those. It uses its magnetic properties to oppose rapid changes in current, absorbing that high-frequency energy and converting it into something harmless, a tiny, imperceptible amount of heat. Think of it like a bouncer at the door of a venue. Regular guests, the useful electrical current, walk straight through without any trouble. But the troublemakers, the high-frequency noise, gets stopped at the door and turned away, quietly, efficiently, without any drama. This is what engineers call frequency selective filtering. The Ferrite bead doesn't block everything. It doesn't weaken your charging current or reduce performance. It specifically targets the frequencies that cause interference, and only those frequencies. It's a surgical solution to what could otherwise be a very messy problem. If you look at most laptop charger cables, you'll notice the cylinder isn't sitting in the middle of the wire. It's almost always near one of the ends, usually the end that connects to the laptop itself. That's not accidental. Engineers chose that placement deliberately based on where interference causes the most damage. The section of cable closest to the laptop is the most critical gateway in the entire charging setup. It's the last point of defense before electrical signals, good or bad, enter the laptop's internal components. By placing the Ferrite bead right at that junction, engineers ensure that any noise traveling down the cable from the power brick gets filtered out before it reaches anything sensitive. At the same time, that placement also helps contain the noise that originates inside the laptop. When your laptop generates high-frequency electromagnetic signals, which it does constantly just by running, those signals can travel back out through the charging cable and start radiating into the room. The Ferrite bead near the laptop intercepts that outgoing noise too, keeping the cable from acting as an unintentional broadcast antenna. It's a two-way filter working in both directions simultaneously, all from that one small cylinder you've been ignoring for years. Here's where it gets interesting. Would your charger still work without the Ferrite bead? Yes, your laptop would still charge. The power would still flow, but the environment around that charger would be noisier. Measurably, documentably noisier. Without the Ferrite bead filtering outgoing interference, the cable becomes a more effective antenna for broadcasting electromagnetic noise. If you have external speakers near your laptop, you might hear a faint but irritating high-pitched whine or buzz, especially when the laptop is under load. If you have an external monitor, certain lighting conditions or screen refresh scenarios might produce subtle flickering. You can never quite pin down. Wireless performance can also take a hit. The 2.4 GHz Wi-Fi band in particular is notoriously vulnerable to interference from electronic devices. A cable broadcasting unchecked EMI near a Wi-Fi adapter can introduce just enough noise to cause packet loss, dropped connections, or reduced speeds. You'd blame your router, your ISP, your walls, and the real culprit would be a cable with a missing Ferrite bead. And on the receiving end, a laptop without that filtering layer is more exposed to interference coming in from the environment. That can manifest as unstable power delivery, which in rare cases contributes to charging inconsistencies or battery calibration issues over time. The Ferrite bead doesn't make the difference between a charger working and not working. It makes the difference between your entire electronic environment running cleanly or running with constant low-level friction. You may have noticed that not every modern charger has that distinctive cylinder. Sleek, modern USB-C chargers, especially from premium manufacturers, often have cables that look completely smooth from end to end. Does that mean they've abandoned EMI filtering? Not at all. What's changed is where, how the filtering happens. Cable shielding technology has advanced significantly. Modern cables often incorporate multiple layers of braided metallic shielding woven directly into the cable structure, which suppresses interference without requiring an external Ferrite bead. The filtering happens inside the cable rather than around it. In other cases, the filtering components have been moved entirely inside the charger brick. Engineers can integrate the equivalent of a Ferrite choke directly onto the circuit board inside the power adapter, eliminating the need for anything visible on the cable itself. But Ferrite beads haven't disappeared from electronics. They're still widely used in applications where the stakes are higher. Medical monitoring equipment, professional audio and video production gear, industrial machinery, aerospace electronics. In any environment where interference isn't just annoying but potentially dangerous or mission critical, the Ferrite bead remains a trusted, reliable solution. That small plastic cylinder on your charger represents something worth appreciating. It's a piece of engineering that exists entirely to solve a problem you never see, never hear, and never think about, because it's doing its job perfectly. It's a reminder that the most effective solutions are often the invisible ones. Components that never demand your attention, never fail dramatically, never announce themselves. They just quietly hold everything together while you focus on what you're actually trying to do. Now, here's the thing. Your charger is just one example. Your home is full of objects exactly like this. Ordinary-looking things with extraordinary hidden functions. The small hole in your pen cap, the extra holes on your sneakers above the lace line, the ridges on the edge of coins, bump on the F and J keys of every keyboard ever made. Each one has a story. Each one has a reason. And each one, once you understand it, makes you look at the ordinary world just a little different. So the real question isn't just why there's a cylinder on your charger. The question is, how many other things around you are quietly doing something you've never once stopped to wonder about?